Okay, today let's build my balance robot type 2. This is a very simplified balancing robot compared to the first balance robot type 1 that I already posted on Thingiverse and up on YouTube. This one, instead of doing the balancing down in the ankle and shifting the body weight and everything like it did, this one works a little differently. We'll start with 2 feet that simply move forward and backward, but they're set at an angle, so there's a middle point where the robot wouldn't normally want to stay. It's going to want to be to one side or the other. So all we have to do is tip the mass of the body in the direction of the foot that we want on the ground. So by shifting the body weight at the right time, you can then make it walk forward or backward or whatever you want. And to do that, I'm using 2 different gear motors. One is the 1x120 biaxial. It's a TT motor when you look them up. In fact, let's just turn this over this way. For example, we're up on eBay. Most common search terms for it are TT motor, smart car. Sometimes they use the word Arduino motor. But TT motor, gear motor, will bring it up. But you can get them both in a 1:120 gear ratio. And if we click on this thing here, and you can get them in a 1x48. Now 1x48 is going to be your fast motor, and your 1x120 is going to be your slow motor. And I use the slow motor to control the walking legs, speed of the walking, and I use the fast motor to tip the body. And I went ahead and just stuck a couple of LEDs which are wired opposite each other. So if you change the polarity of the voltage, one would light or the other would light, and run those to the fast tipping motor, which only gets pulsed in order to tip the body. And that way you can get a nice pulsing action for the eyes of the robot if you want to. So the basic action, and we'll go through the whole build here. I've got a switch up between the legs here. So basically you can see that the legs are just going to be moving back and forth like I said, and the body's going to throw the weight to the sides. So the idea is that if it shifts the weight, then it should be able to walk forward or backward. In fact, you can change the wiring on the motor in there if you want it to walk backwards. It just changes the timing of when it does what it does, and you can go forward or backwards. This isn't the best surface to be trying to walk on, unfortunately, but it's what I've got because this is where I'm going to do the build. And if it doesn't make the tip all the way, then it'll just go backwards. Okay, you got the basic idea of what we're doing here. It's been 3 weeks since I built these, so I probably won't remember exactly how to do it. But this is the body piece. It'll print flat on the bed just like this with no supports. And I guess there is a little bit of prep work we can do. This is the internal mainframe that holds the motors and the switch and all that good kind of stuff. Here's a leg. Prints flat obviously like this, no supports. The other leg. If you decide you want to add the decorative side guns, these are them. I print them vertically, and go ahead and add a little pad for them to print on for stability so they don't tip over before you're done. Then the feet, they're symmetrical. They print flat on the bed like that. And then you have the other part of the leg supports. And down in the feet we're going to put 2 AA battery holders. As you can see, might be easier to see on this one because there'll be a color shift. The battery holder. First thing we'll do is we'll put the leg parts into the foot and then pop the battery holder down in there with some glue to hold it. There's slots provided to tuck the battery wires up through the legs. Then we can bring them up to the body to run to the switch and all that kind of stuff. So we could always, the only way to figure out whether you're putting a foot together right or wrong is you're going to look for the slot that I talked about that the wires go in. Just make sure that that's aiming outward, then you'll know whether you're building a right or a left. Once you pop these in, you're going to want to wiggle them around a little bit, loosen any rough edges are up. I mean, you could just sand them too, but again, there's the slot on this one. And pop them in and out a few times to deburr them. Got pretty good action on that now. Do the same thing with the other foot. Say, just always make sure the slot's facing towards the outside because of the battery holders. Then you'll build your left and right feet the right way. Just like that. You see, I haven't cleaned these parts or done anything. They've been sitting in a bag here for 3 weeks waiting for me to have time to shoot this video. And then you're going to take a battery holder. Particular ones that I have little grooves for tipping the wires out from underneath the bottom side. You could put some hot melt glue or regular glue on there before you pop these in place. I'm just going to put some goop on them and we'll shove them in there. They're going to pop into place pretty good. And if I remember right, you kind of shoehorn them in. I start with this front edge going in first and then just force the back side in. There's little ridges that the battery holder can hit up against so you know when you're all the way in. I'm not quite sure why that one seems to be not quite shoehorned in. There we go. I just didn't apply enough muscle. And we'll let that sit and dry, and we'll do the other one. If you have a choice on the wires being to the front or the back, maybe you have battery holders where they're right in the middle, and it isn't going to make any difference which way you put them on. In this particular case, I'm aiming the wires towards the back so they can get into that leg easier. Just like that. So the battery holder, of course, does two things. One, holds the battery, but two, it also keeps these leg parts in place. So now you've pinned them, you don't have to do anything else with that. And you should be able to take your battery wires and feed them up through that slot that we talked about, and then they'll come out up above like so. And just make sure you leave enough so that the leg can still move. Like so. I'm not watching the monitor at all, so hopefully a lot of this is in frame where you guys can figure out just from what I'm saying what it is you're supposed to be doing. There we go. And what shall we do next? Next, why don't we put some motors in the motor frame, maybe, huh? Or maybe the eyes up in the body. And I talked to you earlier about adding eyes. These are just your standard 5mm LEDs, and these happen to be red because red lighted a lower voltage. And like I say, I wired them opposite. Take the positive from this LED and solder it to the negative of that LED, and the negative of that one to the positive. That way, when you reverse your voltage going to them, one or the other would light. Give you an alternating effect. Throw something on there as a current limiting resistor. Could be anything from 100 ohms to 220 ohms. Doesn't really make any difference on a 3-volt system when you're doing something just for looks. You want to keep this as flat as possible. You can see how I spaced them when I wired them. I just sat them on the front to do it. We're going to pop them in from the inside. But we want this as flat as possible between the two so it doesn't mix in with any of the motors and stuff that we're going to shove in there. And there's no way we're going to keep this really in camera frame, but you know what I'm going to do. I'm just going to take these and try to get my big fat fingers in there and shove them into those eye holes from the inside if possible. There's one. And there's two. That way you can kind of keep the wires back all over to one side and out of the way, and see how everything else just kind of lays flush in there. I'm going to go ahead and put some glue so if someone pokes their fingers on them, they can't poke the LEDs off and they don't have to take the whole thing apart. Again, you could get right in there with some hot melt glue, or if you've got goop, just grab a flat blade screwdriver or something, and I'm going to dab that over the back of that LED. Get another little glob for the other one. Just something to make life easier, because you know people are going to handle it and play with it, because that's what it's all about. It's a toy. In this case, it's kind of a crazy, wacky toy. So, all right. Well, we'll let that sit and do whatever it wants to do, cure up, and I'm digging out the motors. This motor I went ahead and marked. It's the 1 to 120 gear ratio, so this is the slow one. So this is the one that we're going to use for making this thing walk. And it's going to, well, I haven't cleaned this out yet. This main frame part prints flat like this on your printer bed. And there are some places that we need to, so I wouldn't have to print with any supports, I have it bridge a layer. So we need to clean those two places out. And I just take like an X-Acto pointy blade and just get in there and just slice them. It's only one layer of, if you print it 0.2, which is what I printed these parts out, it's just one layer. So it's pretty easy to clean out. Clean those out as best you can. And it seems like there was one other thing. Oh yeah, we need to clean out. We're going to be running some wires. See this slot that's provided here? We're going to be running some wires down through there, so there's a little slot right down here. You need to clean that out also, so that's open. Like that. Great. Hang on. Okay. So let's take our motor. We'll pop it in there like that. There are places provided to put screws in to hold it in place if we want, and I think we want, so I'm going to grab a couple of short 632 screws. Other parts of the world it might be a 4mm or a 3.5 or whatever. Again, if you don't have screws, just put a little glue on the motor and slide it down in there and let it set up. It'd stay there. These screws that I'm using are just left over from old light switches in America. It's what the AC wires go into. I didn't find the best screwdriver. This is kind of a crappy screwdriver, so I'm doing it off camera by holding the part in my knee. Might not be able to do it with a screwdriver. Nope, it's going. Just keeps it in place, no big deal. Okay, now the motor that we're gonna, this is the one that makes the robot walk, so this is the slow motor. The fast motor that does the body tipping, when you order these, you can find them where they're dual shaft or single shaft. In this case, I already had a dual shaft normal fast one, so this is the 1x48, they call them on there, and I just cut off the back part of the shaft. I'm wondering whether I want to go ahead and put that motor in now or whether we should do the wiring first, because it's kind of easier to shove that wiring up, but you can see this motor is just going to slide down in there like that. This is a rubber O-ring. We'll get to that in a minute. I think, since it's been a few weeks since I've done this, maybe we'll go ahead and do some assembly here before we put that front one in. There's two cams. They print flat, no supports. And again, you can either hold them on with screws or you can hold them on with glue. But they're made to fit the shafts. You just want to put them on opposites. So if one's facing up in this case, then you want the other one facing down. Like I say, you could put a little drop of glue on there, or you could, if you've got some screws, I've got some small number 2 screws here, like I use on almost all my projects. Just grab a number 2 and stick it in there. Then I won't have to worry about that coming off. Like so. Okay, well, let's grab a leg and basically it's going to loop around the cam and loop around a post. The same with that one. That's how easy that's going to be to assemble. And then there's these pieces. There'd be 4 of these all together, which print flat, no supports. And again, you can put a little drop of glue on them before you wedge them on, but they should, if your printer's aligned well, they should fit just nice and snug. Maybe I'll put a little drop of glue on there. Don't need much. Because the last thing you want to do is glue the legs so they can't move. I suppose probably the easiest way to make sure you don't glue something you didn't intend to would be to put the glue inside the hole, just a little teeny drop of it, like back inside here, just on one of the walls. And then when you snap the cap on, that should be enough to hold all that stuff in place. And we just do the same thing with the other side. Cam, get your other one. It's good to go. Let's put a little glue on before we pop in the caps. See, the caps really do fit nice and snug. I've actually never had one work loose on its own. I don't even know that they would. I don't know that it's necessary to do any sort of gluing. If you don't glue, then you don't have to worry about running the chance of gluing your legs in place. Alright? I think at this point, if you have the ability, it might be a good idea to test that motor and system and make sure everything is working. I've just got a little battery pack with a couple alligator clips. So I'll just clip onto the motor here. And we'll just see if everything is working. And it appears to be. You can see the legs are going back and forth, and that's all they have to do. So that's good. The wiring, let's get on with that. We're gonna, maybe I better be heating up the soldering gun while we do something else. So let's plug in the old soldering iron, or the metal 3D printer, since basically soldering is FDM printing with metal. We're gonna have two of these battery wires that need to run on up. And I think we have to do the switch one first, because otherwise it gets kind of crowded in here. There's some slots. If you can see that slot there, and maybe we can hit an angle here somewhere. There are little slots where the wires can go to help keep things nice and neat. You don't have to use them, but it could make life easier if your wires were held out of the way where they can't get tangled into stuff. And let's try to grab that one so you can see it just pulls it up to that slot. I'm going to go ahead and leave some slack on it. I'm going to end up soldering the switch to that wire. Then let's grab a black one from this side, because basically you're going to wire the two battery packs in series to get 3 volts. Like that. And I'm using the standard slide switch like I use in all my projects. The mounting holes are at about 19 millimeters, thereabouts, actually like 19.1 or something. And you do have to have some small number 2 screws, one of which I just dropped on the floor, and we know we're never going to find that one again. And I don't think my soldering is going to be where the camera can see it. So use your imagination. Basically, I just tinned the contacts on the switch. And now let's put some solder on the black wire and the red wire that we just ran through those slots. Like so. And just put one wire on one terminal of the switch and another wire on the other. So all we want to be able to do is turn the power on and off at this point. So nothing special going on here. Other than I can't seem to get it to go where I want, so I'm going to try tinning that switch up again. So I may have to put this in my lap to do it, instead of trying to keep it on camera. Alright. So far all we've done is we've taken one wire from one battery holder and one wire from the other, just make sure one's red and one's black, and ran them up to a switch. Now I'm going to try to stick that switch up inside there and screw it in place so that it's out of the way so we can continue on with the rest of the build. Normally this is the kind of stuff I would do off camera, but what the heck. You guys might as well see that it's how it's all done. It's not so easy when it gets this small and my fingers get so big, but let's see if we can't figure it out. Like I say, it's been a few weeks since I've done one. You tend to forget the cheats, you know, the things that you figured out that make things easy to do. I'm not 100% sure. It's getting close. It's getting near where it's gonna go. I guess I could poke at it from the top with a screwdriver, because we do have that hole that the motor is going to eventually nest in. You know, that seemed to work quite well. I'm not thinking maybe I should get the screw sitting in the hole. Fortunately I dropped that one as well. Oh, it's right here. These needle nose seem to be magnetic, so I'm not able to grab it the way I want it, just kind of however it happens to stick to it. There we go. Now let's see if we can jam it from the top. And of course there's no reason that you have to put the switch here. It was just a place where I decided to anchor it. It was unused space, so I went, what the heck. But it looks like it's kind of a pain in the ass to do it that way. Since I can't seem to remember how the heck I did it. Did it twice without any problems that I can remember. I keep wanting to think that somehow I just got my finger in there, but I don't know how, because my fingers are too big. Okay, there it is again. That's about where it's supposed to be. Close. So close. Ooh, I think we're going. Now if I just had that other screw that I dropped earlier. Such a small screw, such a big floor. I think we'll put that other screw in some other time. Anyway, we've got managed to fish that switch around and get the one screw, and the other screw will be easy since the switch is now already held in place. But that gives you a place where you can also tuck some of the excess wire. So these two remaining wires we can also tuck up through the slots in the body, and then run them right on up like I talked about earlier. And you'll see it here once I get one started. It's like that. See how we came up through. Maybe you can't. Can I get the angle right for you? Came up through that slot there. I'm going to do the same thing with the black wire. course, if you don't care about wire management, how things look, you don't have to fuss with any of this part at all. You could certainly just run the wires anywhere you want. My thought was to keep them out of the way. There we go. And if I remember right, I think we need to extend those wires a little bit just to make sure that they get them where we need them to go. So let's see here. Again, I don't believe the soldering. Here, let's angle you down. Just tin this wire up. Extended that one, now let's extend the other one. Red one's around the front. There you go. I don't think there's anything that they're going to short against, but as long as I'm right here, why not, right? A little piece of tape. One less thing to worry about eventually shorting against something. Just like that. And they just come up inside those grooves out of the way. We've got our faster gear motor that we talked about, which now should slide down in here. It should go all the way down, and theoretically we should be able to stick a screw in one of the two holes. You don't really need to put a screw in both holes. I just left it open for whatever you might end up having to use. There we go. Okay. Hot dog, we're getting there. So you've probably been wondering, well, what's going to make the forward motor know when to tip? Well, what we're going to use for that are two small snap action, basically end stop switches, but you can get them with the long lever, and that's what we want. Let's see if I can here we go, view over here on the old eBay. So here, for example, is somebody that's selling 10 of them. The mounting is like 10 millimeters from hole to hole, if that helps you. But the main thing, if you find a switch that visually looks like that, it's going to fit. And you get this nice long lever, because that way we can bend the lever around to where it's going to work. And I can't remember if I did anything special screw-wise. I think I just, in my case, again, you could glue, but I provided holes for number 2s, because I have some. Put that in there. Like that. And then put one over on this side. didn't get something lined up right there. Let's try it again. Oh, I think I had to use a shorter screw on the one side. The motors have a nut or something on one side, not on the other. Something I can't remember. But ended up cracking the print a little bit, so I'm going to end up putting some glue on it, because it structurally doesn't really do anything other than hold those switches, and they're not going to go anywhere. No point reprinting the part, if you know what I mean. So I'm just going to go ahead and put some glue on that part. Like so. The switches are going to need to be set and trimmed because they're longer than what we need. I happen to purposely stop the motor where the legs are pretty much equal and the two rods are pretty much equal. These rods are where they're going to bump against these switches, so just kind of grab the switch and some needle nose and bend them till they just contact the rods, the leg rods. If that doesn't give us the walking action we want, then we'll come back and re-bend them. But snip off the extra. So it isn't sticking up too far. Alright. I was trying to remember if there was anything special I needed to do before I moved on, but I don't think so. The you know, the motors on these little TT things are held in with these plastic straps. Those also make really nice places for tucking wires. So I want to get the power wires to the back. So I'm just going to go ahead and pull it through like that. I'm going to do the same thing with the red one. Because again, that keeps everything out of harm's way, out of the leg mechanics and everything. So now we've got something that looks more or less like that. We're going to wire the switches the same. The idea is if both switches, let's say because you've got a common, you've got a normally open and normally closed. If both sides are wired the same, normally this motor wouldn't be on. But as soon as one switch is moved, now it's the opposite of the other one. The motor is going to run in that direction, or this one is going to run in the opposite direction. And it's only going to do it while the leg is back pushing on it. So that gives you a momentary pulse to the motor that's going to be doing the spinning. So in reality, we just need we need to put positive and negative to any of these that we want it, as long as we alternate them. So I'm going to go from there to there, for example. And yes, I could draw this out on paper for you, but why make this video any longer than it's already going to be, right? It's already going to be too long for most of you. Anything over 15 minutes, you know, is going to way beyond that. I'm going to solder another wire to those contacts, same contacts too, so I'm not too worried about the placement, because the next wire is probably going to make me adjust that anyway. Like so. So here's what we have so far. Just take one of the wires, solder it to the top of one of them, take the other wire, solder it to the middle of the other one. That's all we've done so far. What we're going to do now is just grab any scrap wire you have and bridge across, top to top, middle to middle. Okay? Don't worry about the bottom yet. The bottom's going to go to the tipping motor. So I'm just cutting myself a couple of short lengths of scrap wire so I can bridge the two switches. The wiring on these two switches is a very standard way of how vintage toys that had wired remote controls, how they were made to work, how they reverse the motor actions to get different functions. It's a very simplistic design that works very well. Come back here. Down there. I don't really like the way this solder connection looks here. I'm going to hit it again. There we go, that looks better. Looks like it flowed that time. And let's tin this one up. And let's tin the end of our wires up. See, 3D metal printing. Who would have thought? We've been doing it for 100 years. Additive manufacturing. Liquid metal. Kind of surprised someone hasn't made a 3D printer that extrudes solder and cools it and actually makes things out of solder. Okay, so we've brought our power up from the batteries, we've run them to the switches. We need to run constant power to the walking motor, and it doesn't really have a forward or reverse, because it doesn't, on that walking motor on the cams, no matter what you do there, it's just shuffling the legs forward and backward, and it's going to do that no matter what. So we can hook these up any way we want. So again, just grab yourself some scrap pieces of wire. Tin them up and have at it. I'm going to, let's go ahead and start with the front one. What the heck. Let's see if we can tuck it through that plastic shroud that's holding the motor in place as well. Guess it would have been easier if I hadn't bent the end of the wire over. Try it again. There it goes. Here it comes. And I guess I can try to fish it down to the black one just so everything looks neat. Black to black, red to red. Again, it didn't make any difference on this particular motor because it's just shuffling the feet back and forth. So any polarity would work. It's like that. And that leaves a one wire connection on this motor right here, and we're just going to run it right to there. So we just need a short little wire. Like that. Holy shimoly. Well, at this point, we can stop and test what we've done so far. If we can put some batteries in this sucker. There's one in that foot. And these two battery holders were different. I just noticed that just now. One in that foot. And let's see if our switch works. Okay. So we have our back and forth action. Say it isn't going to go anywhere with that action. In order to get that to accomplish something, you have to tip it at the right time, right? Depending on which way you want to lock. Okay, let's shut that down. Let's wire up this motor. We don't really know the polarity that we need yet. And if we get it wrong, we'll just reverse it. I'm going to try to tin up the motor contacts first. They don't look real clean on this motor. I just soldered a scrap piece of red wire onto one of the terminals. Again, I'm going to tuck it through this motor holding plastic thing. Again, just to keep the wires out of the way. And I'm not going to trim that wire yet because we don't know which side it needs to solder to yet. Because I don't remember from 2 weeks ago when I built the other two. So I'm just going to leave the wire long and tack it onto the bottoms of the switch. And we need another piece of scrap wire like that. Or like anything. And let's put it on the other motor connection. I think I'm going to bring it on over to this same side. There's less wires on this side over here. It's more room for running stuff. There we go. And again, let's just go ahead and leave it long for the moment. We can trim that stuff up, neaten it all up once we know which direction is which. So at this point we should have the legs moving and we should have this motor moving. There it turned, isn't it? Is that showing up on camera? As far as what that means, I don't know. We'll figure that out as we go along here. I think we're almost completely done. Normally I would just solder the eye LEDs to the motor connections here, but we do need to figure out what's forward and what's backward first. The front of the robot is the cam side, and to hold it on, there's a little post which prints flat, no supports required. And in order to make the connection with that other motor in the body, we have these two clutch parts. And again, they print, this one prints flat this way, so those supports are cleanup. This one prints flat, but there's a little bit of cleanup required. What did I do with mine? Knife. Ouch. And of course you could print it with supports and then you wouldn't have to do the cleanup, but I designed the part this way so that it would be easier and quicker, less wasteful, less time. I'm not a big fan of using supports unless you absolutely have to. So what I take is a small rubber O-ring, and again, if you've watched any other videos where we use the O-rings, by the way, this part of the clutch that we just cleaned out, it's going to slip right onto the motor. I believe if I cleaned it out right, yep, it should push all the way on back, see? Then you want to find a rubber O-ring that will fit around that motor shaft. The rubber O-ring is what's going to give us our grabbing power for this clutch against the body. This piece that we showed you here, this cap, will be on the outside of the body with a screw running through it. Like so. To secure everything. Well, let's see. I know these wires for the lights and these long wires up here kind of be in the way for the moment, but I would start by trying to spread the body just a little so that you can force it down till the motor shaft thing pops in. Then the front one will automatically, oops, wrong thing. Front one will automatically line up and you can put that post in there. That gives you your pivot point. Now if we screw this cap on, that will give the body traction to that motor for kicking it back and forth, like so. So let's see which way that sucker's walking. For some reason I think the wires are gotten into the switches, because I can hear a switch clicking and it's sticking. So we're going to have to take a peek in there and see what's hanging up. Not quite sure how I should move the camera to make things easier for you to see. But just gonna try to pry that motor free again. Trying to remember how I did it before. I think you just reach in there with a screwdriver or something. Yeah. Once you get it started, it's able to lift it off. So I was hearing that the switches were hanging up on something, and I think maybe they're a little bit too long and they're dragging on the top of the frame, and I could either just trim them shorter or maybe I can just bend them back on themselves, and that's what I'm going to try first. I'm just going to bend the tops of them back. If that doesn't work, then we'll go ahead and trim them some more. Main thing I was trying to do is keep those from hanging up on something, because the motor kept wanting to stay stuck in one direction until I helped it past that. So let's try this again. Post in the front. I'm not quite sure. There we go. At the back. Okay. Okay, so it's walking backwards. So now we know we have to reverse those two wires so we can walk forwards. So we'll do that. And we'll solder our little eye lights on. And then basically we're done. I mean, we can glue the little gun things to the side, but that's just a cosmetic thing. Oops. I had it out of the hole and then I popped it back in again. There we go. Okay, so we need to reverse our two tip motor wires, and we can shorten them up at the same time. So we'll make this one come over here. And like that. And the remaining one we'll trim off about like this. Tin that up. Goot. So now it should be walking forwards. And we need these two eye light wires. And maybe it'd be easiest to try and solder them right onto the motor, since it's right on top. Or would it be better to have them in the back? I don't know. I don't remember. I don't remember what I did in the past. Let's be brave and just try in the back. It's easier to solder back here. There we go. I think that should be good. Actually, when I say let's solder them in the back is actually the front. So, sorry for making that confusing for those of you that are watching and trying to follow along. In the end, once you know everything's working, again, you could put a little drop of glue and before you shove your pivot plug in the front on. But since we don't really know that it's going to be working right, let's not glue that yet. Okay. Got our clutch on, that on, and let's turn the robot on. Let's see. There it goes. got our eyes flashing. They actually indicate when the tip motor is getting its voltage. So, nothing really left to do. If you like the addition of the guns as far as adding some visual cosmetics to the whole thing. Then I just put some glue on there and just stick them on wherever you like them. I kind of like mine sitting about like so, but that's the last thing to put on. These are printed in that obviously silver, but I'm trying to think of the word they use for the silky silver. So they actually kind of look like brushed aluminum in the end. It's very, very nice filament. And that's it. Go build, enjoy. Just make sure you get the two motors, get the slow one and the fast one, the switches. I mean, all together for the motors, the switches, and the battery holders, you've spent less than $10. And LEDs, of course, cost nothing, and junk wire laying around. The little switches are, you could probably scavenge for something, but even if you didn't have that switch, you could use whatever switch you did have. You could drill a hole and put a toggle switch out the back, or no switch at all. Pop the batteries in and go. Whatever makes you happy. If you wanted to get sophisticated, you could add yourself a little control to it, since just by reversing those two motor wires, it'll make it walk forward or backwards. So you could put an infrared sensor or proximity sensor or something on the robot. So if it got near a wall or something, then it would back up and walk the other way. There's a lot of things you could do with it. It's just a very very simple balance walker with kind of a wacky action. Sometimes it'll do the two-step and walk backwards before it goes forward. It's just meant to be fun, not expensive. A lot less parts to print, so the print time is shorter. You don't have all the gears and all the other things you have to be able to print. So even not your low-end printers should be able to crank it out. All right.